The maximum resolution of digital video cameras varies from one camera to another. In a random sample of 50 digital video cameras, the maximum resolutions found were WVGA, 720p, and 1080i. Of the $0 to $100 cameras, 12 had a maximum resolution of WVGA, 7 had a maximum resolution of 720p, and 4 had a maximum resolution of 1080i. Of the over $100 cameras, 4 had a maximum resolution of WVGA, 14 had a maximum resolution of 720p, and the rest had a maximum resolution of 1080i. A single camera is selected at random. Find the probability 1, 2, 3, 4, 5. So we have 5 questions about this sample of 50 digital video cameras. And the cameras are distinguished by 2 characteristics. We have resolutions and price. So this would indicate that we might want to use a contingency table to summarize the population before we do any calculations. So that's what I'll do first. We have 50 digital video cameras, and they're again distinguished by resolution and price. So across the top of the contingency table, I will put resolution. So we have resolution, and the possible resolutions are WVGA, .720p, and 1080i. And the prices are $0 to $100 or 100 or over 100. So 0 to 100 or over $100. And there are a total of 50 cameras. So that's the first number I'll put in the table. And that's the total number of cameras. So the total of the totals. And that belongs down here in the bottom right hand corner. So that's 50. And now we'll go back up and get some more numbers. So of the $0 to $100 cameras, 12 had a maximum resolution of WVGA, 7 had a maximum resolution of 720p, and 4 had a maximum resolution of 1080i. So we have 12 cameras with a resolution of WVGA and costing $0 to $100. So that belongs here in the box where we have VGA in the column and 0 to 100 in the row. 7 had a maximum resolution of 720p, so we had 7 with a maximum resolution of 720p and a price of $0 to $100. And finally we have 4 of the $0 to $100 cameras with a maximum resolution of 1080i. Of the over $100 cameras, 4 had a maximum resolution of WVGA. So of the over $100 cameras, we had 4 with a maximum resolution of WVGA, 14 with a maximum resolution of 720p, and the rest had a maximum resolution of 1080i. Well, we're not really sure exactly how much the rest is yet, so I'll leave that blank for now and do some adding. So we know that there are 12 plus 7 plus 4 $0 to $100 cameras in this sample. So that's 11 plus 12, that's 23 cameras. So if there were 23 $0 to $100 cameras and a total of 50, that means there must have been 27 cameras over $100. And now we can do some more adding and subtracting here. We have 18 cameras out of the 27 are already accounted for, so we have 18 of these guys. That means there are 9 left at a maximum resolution of 1080i. And finally, we can add up the columns. 12 and 4 make 16, 7 and 14 make 21, and 4 and 9 make 13. And just to double check, we'll add the totals, the column totals, and make sure we get the total. 16 and 21, 37, and 13, indeed, that's 50. So our contingency table looks good, and we can get on to the questions. Number 1, the camera, what is the probability the camera has a maximum resolution of WVGA? Number 1. So this is out of the entire sample. What is the probability the camera has a maximum resolution of WVGA? That is this number here. There are 16 cameras with a maximum resolution of WVGA out of a total of 50 cameras. So 16 50ths is that probability. Number 2. What is the probability the camera has a maximum resolution of 1080i and costs between $0 and $100? Okay, maximum resolution of 1080i and costs between $0 and $100. That's this number here. 4 cameras had a 1080i maximum resolution and cost between $0 and $100. And since we're talking about picking one from the entire sample, that's 4 50ths. Number 3. What is the probability the camera's maximum resolution is not 720p? Well, that means it's either 1080i or WVGA, because it's not 720p, and there are a total of 29 cameras that are not 720p. So 16 plus 13, that's 29. Again, there's a total of 50 cameras. Number 4. The camera's maximum resolution is WVGA or it costs over $100. So, according to our contingency table, we have 16 cameras with a maximum resolution of VGA, and costing over $100 we have 27, but we have to be very careful. We can't just add 27 plus 16 to get the total number of cameras with a maximum resolution of WVGA or costing over $100. If we do that, we end up adding this box twice. Once because it's over $100 and once because it's WVGA. So what we really need is we just need to add these numbers here. We need to add these numbers here. These are all the numbers that give us cameras that are over $100 or maximum resolution WVGA. And since we've already added this entire row, it's 27. All we have to do is add 12 to that, and we have 39 50ths for our final answer. Number 5. The camera costs over $100 given that its maximum resolution is 1080i. Okay, so what's the probability of that? We're given that its maximum resolution is 1080i. So what we have to do is realize that we're working with a reduced sample space. Our entire sample space now only has 13 cameras in it. It's the ones with a maximum resolution of 1080i. So immediately we know that the denominator is 13, and now we're looking for the probability the camera costs over $100. So within that reduced sample space, within the cameras of the 1080i resolution, we have to look how many have a cost of over $100, and that's right here. So the answer is 9/13.